started, because I think we talked about force compass last time and logistics of the class. So this will be our first day of actually doing any math. Alrighty, so here is our first problem. I'm not going to just go into the problem. I'm going to give you the actual review of the exponential laws, and that would be the product rule, and you need to know them by name. You sure don't need to go, well, that's where you take that there exponent and you dangle, add, and subtract. You need to know the name of it. Product rule says that if you have the same base and you are multiplying the two terms, what do you do to the exponents? You add them here. That's right, class. And that's what that means. The quotient rule says that if you have two terms with the same base and you are dividing them, what do you do to the exponents? Subtract them, Hubert. That's right, class. Okay? So you got the quotient rule and the product rule. Very basic rules. And they're also basic for your logarithmic rules that we're going to get into also. Alright, so you got those two rules, number 1 and number 2. Now, what about number 3 and number 4? Well, number 3, let's just number these. Number 3 is called the inverse rule. And the inverse rule is basically for negative what? Exponents. Negative exponents is something that you don't like. Alright, it's something that if you leave a problem in terms of a negative exponent, some constructors will mark it wrong. So, what do? Well, you have 1 over a to the negative n, then you flip it. 1 over, flip it, make it flip the same, a to the n over 1. Anytime you have a negative exponent, you flip it. If I have a to the negative n over something, 1 or whatever, I flip it and it becomes 1 over a to the n. So anytime you have a negative exponent, you can flip it. Now that doesn't mean if you have a 2 under here, the 2 comes up here. No, that doesn't mean what that means. What it means is if you have a to the n, let's say you have 2a to the negative n. Well, that 2 is over a 1, and that a to the negative n is over 1. But do you flip them both? No, you just flip this one. And the answer would be 2 over a to the positive n. Okay? You don't flip everything. You just flip just the exponent that has the what? Negative in front of it. Alright? That's 3. That's called the inverse rule. 4 would be the inverse power rule. Now the inverse power rule is different from the inverse rule, whereas the inverse rule doesn't have parentheses. The inverse power rule has parentheses. So, and you use it in case you have a negative exponent. But it's a different animal because it has parentheses. So a to the x over a b to the n raised to the negative w power. The negative is on the outside of the parentheses, therefore it's a bigger quantity than 1 over x to the negative n. So what you do here is you flip what's on the inside of the parentheses, and that makes this the positive. Now, the first thing somebody says is, well, Hubert, I thought you just said if you flipped something, it made the variable positive on the one that you flipped. Well, that was in the inverse rule. This is not the inverse rule. This is the inverse power rule. This is on the inside of the set of parentheses, which is a totally different problem. So don't think too much. Just do what I say. Okay? Don't think too much. Different animal. You don't use this very much. The first two you use a lot. Okay, that's power rule. Okay. Gotta go back and do power rule. Forgot all about it. Call this number 5. Sorry. Call this one number 5. I gotta put the power rule on. Number 4 is the inverse rule. I'll put the power rule down here. You gotta read that something. Number 5 down, and number 3 down here is called the power rule. These 3 are used for mechanics. In other words, in mechanics, you use these 3. To get rid of a negative exponent, use fourth and fifth. So those are more for aesthetics. These are more for actually doing the work. Power rule says if you have an exponent raised to another exponent, what do you do to the exponents?
Multiply.
Multiply. It's the only time you multiply. That's the power rule. Now, all of you this should be knocking the top of the blues. You should have covered this before. And I always add one more. Inverse power rule, I always add one more to it, and I just call this the rational exponent rule. And that's so you won't run into it like a brick wall later on and say, I've never seen it before. Okay, rational exponent rule, you can call this number 6 if you want to. And all you got to do is write the square root of x to the first power is equal to x to the 1 over 2, which is exponent over what? Index. In other words, whenever you need to rewrite a radical, you need to rewrite it as an exponent, a rational exponent. You just take the exponent right here, and you put it over the what? Index. Okay. Now you're going to need that in calculus because calculus and radicals do not mix. Whenever you see this in calculus, first thing you do, you don't even think about the calculus. First thing you do when you see one of these is you turn it into this. One of the first rules of calculus. Okay? Now that's your rational exponent. Now, you're not going to see the number 6 until later, but it's nice to have it, especially if you've never seen it before. All right, so again, that's review. A lot of you should say, oh yeah, I remember doing those. I don't remember number 6, but I remember 1 through 5. You should remember 1 through 3 especially. 1 through 3 is kind of like the meat and potatoes. 4 and 5 is kind of like the
chicken and the rice.
No. No, the meat and potatoes is what you need to actually do the work. The 4 and the 5 is the dessert. Okay, you don't necessarily need it, but it kind of helps to get rid of the negative exponents whenever you have one. And the other rule, the numbers 5 rule, is kind of easier to deal with exponents when they're positive. So you can flip what's on the inside and make it positive and make it easier to work with. Not a big deal. And if you see your exponential rules like the following, do these have the same basis?
Yes.
Okay, they have the same basis. The -3 is the same as the negative 3 here. So what do you do to the exponents?
Oh,
Add 'em.
Add 'em.
It'd be negative 3 to the 11th power. Negative 3 to the 11th power. Okay? This is 9 to the what power?
To the fourth.
9 to the 4th. You multiply the exponents. I'm interested in, okay? This is a binomial. I don't really care about that. I want you to be able to, this is a trinomial. The degree is the highest degree of the, so that would be 8ab to the second. You got a degree of 3 because 2 plus 1 is 3, or the second order, and then it is a trinomial. I'm not going to worry about that. That's not detrimental to you passing this class. Being able to add, you should be able to add that one. Go ahead and just do that right quick in your head. See what you get. I'll blow it up for you. Just make sure you can knock the cobwebs loose on adding polynomials. That says 5x squared minus 7x plus 25, parentheses, plus, parentheses, 7x squared plus 9x minus 52. Now what's 5x squared plus 7x squared?
12x.
So you take your handy dandy cursor and put it in the box. That'll be 12x, then you'll type x, shift up, and squared. Alright, what's negative 7x plus 9x? So that'd be a positive 2x. And then what is positive 52 minus 50? That'd be negative 25. Plus 2 is negative 27. And dang old check answer, dang old feel good about yourself. So you don't have to wear sunglasses in the building. Alright, what's the biggest problem here? I'm not going to do it, but what's the biggest problem in this problem right here? On the last one. That's what'll get you is the negative. Make sure that you don't just distribute one time, you distribute what? 2 times. So that'd be a positive 2x squared minus what? Minus 9. Make sure you make that adjustment. What kind of rule do we use for this problem? FOIL. Pronounce it however you'd like. And let's do this one. FOIL method. First, 7r times 8r. Outer or outside, depending on where you're from, plus 3 times 7r. Inner or inside, 7r times 8r. And then last is negative 1 times negative positive 3. I think the inside is missing. Thank you. I don't do that. I didn't do inside. I did it right here. Negative 1 and 8r. That better? First, outside, inside, and last. 7r times 8r is dang old 56. R squared. I always get 7 times 8 and 6 times 8 messed up, so I hope that's right. 7 times 8 is 56. Plus 21r minus 8r minus 3. And dang old 21 minus 8 was 13. So 56 r squared plus 13r minus 3. And that's how you do the FOIL method. Pronounce it however you like. Again, not cobweb loose. That's all this section is. Not a lot of pressure, just not cobweb loose. I didn't see the answer, but anyway, it didn't give us the answer. Why didn't it give us the answer? Oh well, it's supposed to. Oh shoot. Sorry. I guess that was this one. Alright, what else we got? That's distributive law, FOIL. Okay, shortcuts. Shortcuts I always have to go over in college algebra because people forget. I even have to go over the shortcuts in Calc 1 because people forget them. So you better not forget them. Shortcuts. Now I call them shortcuts. I don't know what they're called. They're called a bunch of names, but I just call them shortcuts. 1, a plus b quantity squared is equal to a squared plus 2ab plus b squared. A minus b quantity squared is equal to a squared minus 2ab plus b squared. 3, a squared minus b squared is equal to a plus b times a minus b. Give me a second to write those down. Number 4, a cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. And then number 5, a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. So there's 5 shortcuts. Make sure you know them. Make sure you know how to use them. If you go from one side to the other, it's multiplying. If you go from the other side, from the right side to the left side on the first 2, I think you are multiplying this way. Multiplying this way and multiplying this way. When you go the opposite way of those, you are factoring. So which one does this look like? Number 1. So which one does it look like? Does it look like the left side or does it look like the right side? Looks like the left, so that means your answer is going to look like the right. So what's A? 7x. So your answer is 49 x squared plus 28 xy plus what? 4y squared. Now, if you did not get this right here, like when I did it, then you need to go back and do some brushing up. Because you should be able to get that and go, okay, I remember that. And if you're saying, where'd 28 come from? Then you need to review. So I know somebody out there is going, where'd 28 come from? I don't know where 49x or I don't know where 4y come. Where's 428? Don't raise your hand. Don't say you're picking on me. No, I don't know. Nobody, I don't know. All I know is if you don't know how I got this, especially at 28xy, then you need to review over this. Okay? Or send me in office hours or send me in if you got a homework question. Question on that one? All right, that's your answer. Let's go to the next page. What does that one look like? So what's your answer there? 16t squared minus 16tr plus 4r squared. Or 4r to the fourth. I'm sorry, wait a minute. Let me back up. That'd be 16t squared minus 16tr squared plus 4r to the fourth power. And how do you know that? Well, put it in right here. What's A? A is 4t. Well, what's 4t squared? 20 squared. 16t squared. And then 2 times A. 2 times A is, that's 8A, 8t. And then 8t times 2, 8 times 2 is 16. And then r squared is tr squared. So that's how you get that one. And then what's B? 2t squared. And what, 2r squared? And what's 2r squared raised to the second power? 4r to the what? To the fourth. So you should be able to use those, and you should be saying, okay, I remember those from 102. Or Algebra 2, whatever the case may be. What does that one look like?
Which one? Oh, that one.
Yeah. 4p minus 2 plus q raised to the second power. Looks like number 1, Hubert. That's right, class. Looks like number 1. Why? Well, just because you got 2 terms in the first one doesn't mean that you just write it off as another problem. What's A? A is 4p minus 2. What is Q? What is B? Q. You plug and chug. You might have to go further, but let's go ahead and do it. A plus B, quantity squared, is equal to A squared plus 2AB plus B squared. So let's just do this. A plus B, oops. Hold on a minute. Let's try something more. Now, A plus B, quantity squared. So what's A? 4p minus 2. What is B? Q. So now you just plug and chug. Plug and chug, down over parentheses squared plus 2 times parentheses, parentheses plus parentheses squared. And what goes in the A spot? 4p minus 2. 4p minus 2. And what goes in the B spot? Oh yeah, you gotta sort that number 2 here, so finish that out. So that's gonna be 16p squared minus 16 what? P plus what? Plus 4. And that takes care of that. I'm just gonna put that in brackets. So that's that right there. Plus 2q times 4p minus 2 plus q squared. And I don't foresee any of this doing anything, but you could distribute that and get 8qp, 2q. I don't see any 2q's over here, so it's not going to. And then 2q times negative 2 is negative 4q. I don't see any other q's, so that's pretty much it. I don't know what they want. If they want it all written as 1 and in parentheses or whatever. See what they got. Q squared, there's our Q squared, plus 4, minus 4Q, minus 4Q is right here, plus 8PQ, plus 8PQ is right there, minus 16P, oops, well, minus 16P plus 16P squared, and there's the 4 right there. So it comes out right. We feel good about ourselves? Okay, we don't know. Use the FOIL method. That's pretty simple. I'm going to let y'all do that for homework. I'm not going to bring that up. Which one's that one look like? Shortcut number what? Number 2. Good. So that'd be 16x squared minus 56x plus 49. Use the FOIL. What does this one look like? Shortcut number 1. Good. I think I heard 1. Or what? 1 of the 2. Y'all about sleepy in here yet? Oh man, I believe it's the lights being off. I don't know who turned off that back light. They're not supposed to. Okay. Add. What do you do first on this one? Distribute the P and distribute the 2 and then combine like terms and simplify. I'm not going to spend time on those because I don't want to insult your intelligence. Y'all have made it through this far, so hopefully you can, but that's the first section. That's R1. That should be in some of your homework problems. Huh? Is it? I don't know. I don't know how many is in there. Alright, so let's finish that and let's go to R2. These are all review sections that are in the, I just gave you a review 102 and how many problems I give y'all? Y'all know? Y'all check that first? Okay. There's just a conglomeration of these that I'm working on for you. So study plan for R2. That's more confusing. I'm not going to give you that on a test. Alright, now, when you factor out a common term, do you factor out the highest degree or the lowest degree? Nope, you factor out the lowest degree. Whenever you're dealing with exponents, you factor out the lowest. When you factor out a common term, you factor out the lowest. Whenever you factor out using the lowest. So what's in common? K to the 6th, M to the 5th. Well, K to the 8th, M to the 5th. And K to the 6th, M to the 6th. So in reference to M, I'm going to pull out M to the what? 5th. And in reference to K, I'm going to pull out K to the what? 6th. So you should be factoring out K to the, and what's in common with 2, 4, and 10? 2. So you should be factoring out 2, K to the, what, no, not K to the 6th. Go to K, okay, I'm sorry. K to the 6th, M to the what? And that's it, right? Okay, and that should give you an answer. Alright, so I'm not gonna make you mad by doing that one. I'm gonna just let y'all see the answer. Yep, 2K to the 6th, M to the 5th, and then whatever's left over, that's what's left over. Grouping. What kind of grouping are they asking for? Well, there's 2 types of grouping. Now, some of you should know this from your 102. There's 3 by 1 and 2 by 2. Which one is this one? 2 by 2 or 3 by 1? Why? Well, there's 4 terms. There's also could be 4 terms with the other type. I'm sorry, I just lost my train of thought. 3 by 1. 3 by 1 has more perfect squares in it. This one doesn't have hardly any perfect squares in it. Tell me where a perfect square is. 4. That's it. But a perfect square, if you had a 3 by 1, it would be like 16s squared plus 4 times 2 is 8 times 2 is 16x or 16t plus, I'm trying to give you a bunch of squares and then maybe another 4 and then minus, not 4, but 16 and then minus 4. Oh, that's 16s or whatever. I'm trying to give you something. In other words, there's a whole lot more perfect squares than there are in this one. This one is 2 by 2. Why? So that's all you got to work with. You don't have any squares. You don't have anything. So group the first 2 together and the what? The last 2. Or you could maneuver them around however you wanted to, but that's probably what I would do, because you could factor out a t out of the first 2, and there's not much you can factor out of the second 2 except the negative. Huh?
-1.
Yeah, -1. But you can factor out -1. Trying to see if you could rearrange these in any other. The 20 maybe. Yeah, you could factor out that. You could factor out the switch the 20 and the 3s. You could factor that around, and that would give you a little bit more numbers, and maybe do away with the minus symbol. I don't know, but let's do this one. So we could factor out, I don't know, that 3 and that s, sure, I don't know. Let's try that. 15 st minus 3s plus 20t minus 4. Yeah, I ain't taking my drugs today. 20t minus 4. Group the first 2 and the last 2. What's in common here? 3s. And that'll leave what? 5t minus what? 1? And then what's in common here? And then what does that leave you? Now what's happy about this? Why are we happy? No. Why are we happy? Well, what do you see that's in common? 5t minus 1. Is that what you want? You want something in common? Yes. So, what's in common? 5t minus 1. So you bring that down as something in common. And then what's left over?
Yes.
That's 4 in this unit. You see, that one was you were able to do it, but you had to manipulate it a little bit. Yes, ma'am.
Why wouldn't you say that 5t plus minus 1 is squared?
Because what is the operation between the 2? What's the operation? So, what's 3x plus 4x? 3x plus 4x is 7x. You just brought this down. 5t minus 1 is just like x. Yes, sir.
Well, you can group them anyway when you first start out. Just group them like currently.
Well, you got to group them to where you can have that 5t minus 1 is the key. If you don't get these 2 to match, you're in the same boat that you started. I didn't like it because the way it was set up right here. Do you see anything in common right here? That's usually a dead giveaway. If there's nothing in common here and you got something in common here, these 2 are never going to match. And you have to have those 2 match in order to simplify the problem down. Because 2x plus 2x is 4x. 5t minus 1 and 5t minus 1 comes down as a 5t plus 1 or 5t minus 1. This is just like 3x plus 4x is 7x. Now that's a 2 by 2. Well, what does a 3 by 1 look like? Three by one grouping looks something like this. How many perfect squares do we have in that problem? Nope. Huh? 3. Name them. That's not rhetorical. I want you to name them. That's what I heard. I love it when y'all are confident. When y'all are confident, I hear the answer. When y'all are not confident, it's okay, the x squared. What else? Y squared. And the 4. How many we got? How many do we have in the previous problem? Zilch. Which one has more? This one. So that's a dead giveaway to 3 by 1. What is 3 by 1? You group the what? First 3 and the what? Alright, finish it. Finish it. I don't know what to do next. Well, what you got on the left hand side? Shortcut number what? Shortcut number 2, Hubert. That's right. Or shortcut number 1, Hubert. That's right. I'm going to see it and take a nap while y'all finish. You turn those lights off, people. That's what you do. You want us to go to sleep. I think that's what you do. Huh? No, I'm going to turn the back light on. I got to. I'm about to go to sleep. I think y'all did it on purpose. Electric heating myself. That's the wrong line. After 4 classes, my brain gets to be mush. I'm sorry, people. Because Monday and Wednesday are rough on me. All right. So what does that give you on the first problem, on the first trinomial? X plus what? 2. X plus 2, quantity what? X plus 2 raised to the second power. That's shortcut number 1. Minus y squared. And then what is this? Shortcut number 3, Hubert. That's right. A squared minus what? B squared is equal to A plus B times what? A minus B. That's your final answer. Now, in all fairness to your Math 102 teacher or your Algebra 2 teacher, 9 times out of 10, your Algebra 2 teacher or your 102 teacher is going to hammer reverse FOIL and shortcuts before they hammer these. Okay? So, chances are you may not have covered a lot of these, or the 2 by 2 or the 4 by 1, 3 by 1s, because usually the algebra teacher is trying to get you to learn how to use reverse FOIL and the 5 shortcuts. So don't feel bad if your cobwebs are a little bit thicker on this. It's normal. And these are not used a lot. You know, if you're given 100 problems on a test, you're talking about 30% here, because these are not used. Most of your problems, if I gave you a factoring test, would be the shortcuts, the 5 shortcuts, and reverse FOIL. Pronounce it however you like. Aprende? Alright, that's 2 by, yeah, that's 2 by 2. Alright. I don't want to do that one because that's got a common that's got a common factor. I want to do a reverse FOIL just without. No, they're doing shortcuts. I'm sorry. Alright, well let's do shortcuts. If I wanted to, hold on. That one's shortcut number what? No, 3. Difference of 2 what? Squares. What is the square root of 16r squared? What is the square root of 121? 11. So your answer is 4r plus 11, 4r minus 11. And you feel good about yourself. That one, same thing. Shortcut number 4. No, shortcut number 3. Trying to see if it would be, no, it's not shortcut number 3 and number 5 because you can't take the cube root of the 4th power and you can't take the cube root of 2. So, shortcut number 3. Shortcut number 3. Yeah, I'm sorry. Shortcut number, it's not square root. Why is it not square root? There's 2 indicators that says this is a perfect square. Excuse me. What are they? Well, you can't take the square root of 8, Hubert. That's right, class, you can't. What else can you not do? Can't take the square root of the cube, Hubert. That's right, class. Y'all suck. Alright. You can't take the square root of 8, and you can't take the square root of what? X cubed. So, if you can't take the square root, that knocks out how many of the shortcuts? The first 3. So that means you're going to have to revert to number 5. Why didn't I say 4? Because it's a minus sign. So the only one you could be able to do is shortcut number 5. I'm sorry, 4. No, 5. So what is the cube root of 8x cubed? 2x. So a is equal to 2x. And b is equal to, I'll do that, square root of 1 is 1. So b is 1. So all you got to do now is plug and chug into shortcut number 4. Which would be what? A cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. So that'd be 2x. Let's do it. 2x minus 1 times 4x squared plus 2x plus 1. One done. That's it. God dang, I don't know what you're doing here. Dang old cares for states. I was going to do some reverse FOIL, but it doesn't look like I'm going to be able to. Factor by any method. I'd factor, I'd group 2 by 2. Those are all shortcuts. I'm not going to spend a lot of time on those because hopefully you already know how to use them. So R3. What the? Did I hit something wrong? Oh. Sorry about that. Y'all keep it settled down now, okay? Keep it quiet. R3, what is the domain of a function?
It is the X.
It is the X. It is the X. It's the input values for
The X.
X. It's the input values for X. So if I tell you to only use -2 to +2, what's the domain of the function? -2 to what? +2. Is there a 3 in your domain? No. Can you use 5? No. You can only use -2 to what? Now, if you can only use -2 to +2, what will that affect? Your values for what? Comes after X. Y. Good. Which is the range. So if I plug in, let me give you an example. I'll show you an example. This is very important that you understand domain and range, especially if you haven't had it in a while. Just use a dang old regular parabola. And 0, 0, 1, 1, 2, 1, 2, 3, 4, 1, 2, 1, 2, 3, 4. One, two, three. And 2. All right, use your imagination. Now, if I take my handy dandy eraser and I erase this guy right there and this guy right here, then I have just manipulated the what? Not only did I manipulate the domain, but I also manipulated the what? The range by doing away with what? The arrowheads, depending on where you're from. A-R-R-O-W. Pronounce it however you like. Arrowheads. So now my domain, what is my domain in this universe?
3.
Well, we read from left to right. So -3 is what? Domain is -3 to +3. Then if the domain is affected, what else is affected? The range. So what is our range? It used to go on to infinity, but now it doesn't. Where does it go to? 0 to what? 9. That's right, Pat. No. Where does the function exist? 0. And where does it end? Where does it end?
Right there.
And y is equal to what? 9. Because what you get when you plug in 3 squared, here's 3. 3 squared is what? 9. -3 squared is what?
9.
So what's the highest product that your domain can produce? 9. And that's the whole point behind domain and range. You got to think of, for some of you space geeks, for some of you technic geeks, I like to consider myself I'm a Trekkie. I like space, I like Star Trek. I like Star Wars, okay, but I like Star Trek. But if you think there's one episode where the Enterprise is vanishing, and that's because the warp bubble is bigger than the ship, but the warp bubble is collapsing. and the warp bubble is collapsing like this. So if you are caught right there at the warp bubble, you vanish because it comes in and you're gone. So your universe is only as big as that bubble. How big is our universe here? From -3 to what?
3.
What if I want to use 5 as x? You can't. It doesn't exist. And that's what domain is. Domain is the numbers that you can use in the function. And the domain directly affects the what? The range. And you feel good about yourself. So, how do you find the domain of this function? Well, you got to find where x blows the function up. Because you cannot have a function if the function blows up. You can't do it. Now, a lot of you are saying, what does blow up mean? What does that mean? Well, that's a term that we use at Clemson. I don't know if they use it now, but it's basically when a function does something weird, it blows up. And when you get a EROR in your calculator, that means it's blowed up somewhere. In other words, it won't work. Now, you have to worry about the domain with two types of functions. You have to worry, and you might want to write this down if you've never understood it. You have to worry about two functions. Two types of functions with your domain. And that is a rational function and a radical function. Why do you need to be weary of your domain with a rational function and a radical function? Somebody help me out. Why? Such a disappointment. What's a rational function? Well, that's what that is. Somebody tell me what rational means. Rational means ratio, oral ratio. What's the ratio?
It's a fraction.
There you go. You're on the ball, man. X plus 1 over x minus 2. What can you not have in a fraction?
Decimal.
No, you're wrong. You're such a disappointment. Put that hat on and cover up your face. What can you not have in a rational function? Close. What can you not have in a rational function? Can you not have in a rational function?
Negative denominator.
No, you said negative. I said you're getting close. Zero. Where? What can you not have zero?
Well, that's
Function
what I
will
was
blow
getting
up.
at. That's what I was getting at when I was saying x might make the opposite.
Okay, I'm sorry. Why? Well, get your calculator out, because some of y'all go to the bathroom with your calculator. Some of you name it. Some of you have a little pillow and a little bed for it. In other words, y'all think it's the Bible. So punch in the calculator. 5 divided by 0. What will it give you? An ERROR. Okay? And that means that the function blows up because 0 cannot be in the denominator. What is a radical function? You take the square root of 0. What can you not have in a radical function?
Zero.
When you have 0, square root of 0 is 0.
Negative square root.
Can't have a negative. So you cannot have a negative function or it'll blow up. So these are the two that you need to worry about. Which one is this one? Rational. Good. So set the denominator equal to what? 7x plus 13 is equal to 0. So we're going to find out what number will give us the 0 in the denominator. And we can use any number in the world except for that number, because what will that number do? Blow up the function. So subtract 13. Divide by 7. So x cannot equal negative 13 sevenths. So what's the domain of this function? All numbers except for what? That's it. You put that in there however you want. Same thing with the radical. Except with the radical, you've got to think what numbers will give you a negative. So let's do that one that I just wrote down on the board right there. What do you do with that radicandus? Set it equal to what? Now, x equals -2 will give you what? 0. You can have 0, but what can you not have? Negative. So you use -3. Use -4, -5. What will -3, 4, and 5 give you? What? -3 will give us a what? A negative. What will -4 give us? So we can use all numbers as long as they are greater than or equal to what? -2. So x is greater than or equal to -2. That's the domain of that function. So your domain is what can exist in your universe. Depending on what the instructions say, what the test says, or what the teacher says. Now, a while ago, I told you that the only numbers that existed in your domain is -3 to 3. I have affected the domain. I have told you that your world exists of 3 to +3. There's no such thing as an 8-pack. Okay? Why? Because you don't have a 4. There's no such thing. In your world, it's only a base of 3. 1, 2, 3 to the right, and 1, 2, 3 to the left. Therefore, your range only exists from 0 to what? To 9. Now, when the domain is not affected, or I haven't put any restrictions on the domain, then you go to this and you say, okay, set the denominator equal to 0, and I can use any number I want to, but I cannot use 2. I can't use 2 here. And I can't use -2. I can use any number greater than -2 in this one. And you feel good about yourself. So here we go ahead and put here the domain exists of x can equal to any number except for -13/7. And we feel good about ourselves. Same thing there. All these set the denominator equal to what? 0. All right, see this problem right here? These problems you do in first semester calculus, the first couple of weeks in first semester calculus, and people forget how to do them. People fail first semester calculus because they forget what we're doing in this classroom today. They forget by the time they take trig, and they forget. Keep the 102 notebook and keep this notebook. And the week before you start calculus, you go over these notebooks because it's going to get you when you take first variable calculus and they ask you to solve this and you're going to go, oh, I don't know how to do that. And meanwhile, 2 or 3 minutes later, they're already on another chapter of algebra and you're still trying to figure out how to do this. How do you do it? Well, you factor out a common term. Let's factor out a common term. What's in common with the top? What's in common with the bottom? And what do you get? What happens to the y minus 2's? And that's what you're going to be doing in the first week of first semester calculus. So you're just going to have a limit out here. Limit as y goes to infinity. And then you're going to do this and you're going to say the answer is 3/7. Because these two cancel out. But see, you see where you could easily forget how to do this. Some of y'all forgot about domain and range already. Some of y'all forgot about the shortcut. If you don't stay on this stuff, you will forget it. And you'll forget at the worst time, and that's the first year of calculus. Here's one. Limit as z approaches infinity, and they'll just throw it, so that'll be a test question, and you're supposed to solve it. So what are you going to do? Factor. A trinomial in algebra is worthless unless you what? Unless you factor, using a reverse FOIL or a shortcut. Go ahead and do it. That means you need to start writing down pencil, paper. And since they're the same factors, only different signs, you shouldn't have to take that long. Z, 5 and 7. Then go negative and negative over Z, and that's going to be a positive 7 and a negative what? And what happens? You get Z minus 7 over Z plus 7. That's your answer. Now, right now, some of you are going, golly, how do you get those signs? If you're one of those people, you need to be going over reverse FOIL. All right? Go over it right quick for you. In this problem, let's go with Z. Break up the first term, starting with Z. Break up the last term, starting with 1. 1 times 35, 2, 3, 4, 5 times 7. 1 and 35, 5 and 7. Add or subtract this one, add or subtract this one. We want a 12. We'll see. 1 and 35 will give us a 36 or a 34. 7 and 5 will give us a 2 or a 12. So it's not 35 and 1, so it's got to be what? 5 and 7. So you put a 5 and a 7 there. This term, this sign right here means that the largest number has to be negative. So what's larger, 7 or 5?
7.
7. So you put a negative right there. What does this sign right here say? This positive says what? That both your signs have to be what? Like. So that's negative. What is this one? Negative. Negative, same thing with these two. Now, luckily, they're the same numbers. You just got to find the sign. So Z, 7 and 5. This tells us that the largest number has to be positive. Which one's the largest number? 7. So this is positive. What does this say? Like or unlike? Unlike. So if this is positive, this is negative. And that's the reverse FOIL. So you should remember those. If not, you can go over that video for 500 or 600 times if you need to. That's why I put it on there. So you can feel good about yourself. Alright? What do you do on this one? Well, is there such thing as division by fractions? Yes or no?
Yeah.
Well, do you divide or do you multiply by the reciprocal?
No.
You multiply, so there is no such thing as divide. You multiply by the reciprocal. So go ahead and fix this because it needs to be fixed because right now it says dividing and you need to fix that. Then after you fix it, you break up everything and see if you can cancel out something. See, I done made him mad. He's leaving. What's your last name?
Woods.
Woods. I need to write. Did I take roll yet? Okay, I need to do that. All right, get on out of here. While y'all are doing that one. All right, Miss Anderson here. Barron. Barron. Yo, Barron. Okay, Borf. Borf. Crane. Crenshaw. DeVore. Evans is here. Fisher. Hall. Keller is here. Lou is here. Moore. Hello, Moore. No more. Nix.
Yeah.
Pace is here. Page. No Page. Payella. Pahela.
Here.
Okay. Pruitt. Saab is Sab. Saab. Well, I got part of it. Okay. Sloger. No Sloger. Stone. Walton.
Here.
And Woods just left. Okay, so the only people that are absent is Sloger and Page and Moore and Crenshaw, Borf, and Barrett. All right, that's done. Get out of that. I submitted it. Oh my gosh, I didn't submit one of my attendances, and all 30 people were absent. And the weekend, I bet I got 50 emails. I wasn't absent. I wasn't absent. Oh Lord. People, let me ask you a question. If you're here, and I go through and I count you here, and just because I didn't hit a submit button, you think I'm gonna mark you absent? You really think I'm gonna mark you absent? Called a mistake. I had people go happy squirrel on me, or whatever his name is. What's the squirrel's name? The hedge. Y'all don't know the squirrel's name?
Hey.
It's Happy or Happy. Hammy.
Yeah.
Hammy squirrel. If y'all never seen Hammy, he can't talk because he's just stressed out. And that's the way y'all get sometimes. Y'all just start going crazy and, oh my God, he didn't count me here. It's the weekend. I need to write him 15 emails. And I'm going to ignore every one of them till Monday, because Monday is when I can do something about it. All right, 18 z to the 9th over 2z to the 7th times 6z to the 7th over 81z. Now, what happens to the z to the 7th? They cancel out. 2 will go into 6 how many times? 3. This z will cancel with this z and leave z to the 8th. And 8 will go into 18. Well, 2 will go into this guy 4 times. 2 will go into this guy 9 times, right? And 9 times 3 is what?
Can't you factor out 9 out of this? Maybe 9 goes to 18 two times, 9 goes to 81 9 times?
Yep, what are you going to do with the 9? You can't just, you can't factor out because this is multiplication and these are just one terms. You have to cancel. You only factor out of a thing that's got, if you had 9x plus 4, or 9x plus 18, that's a binomial. You can factor out here. We don't have any binomials here. These are all monomials. But I think that's what you're talking about. I think you're talking about taking this 9 and canceling, and you can do that. But you have to cancel, you can't cancel the 3 and the 9 because they're across from each other.
No.
So you get 27 z to the 8 over what? 4. Now once you get to this point, if you can factor anything else, then go for it. The 27 is only divisible by 3 and 9, and 4 is only divisible by 2, so I think that should be it. Okay. Question. Well, let's see what the answer is. Let's make sure I didn't make a mistake.
What I was saying, it would come out to 2/3 Z8.
Well, you're right. I must have done something. What did I do wrong?
Like, when you factor the 9 out, why is the 18 up there not turned into a 2 and the 81 not turned into a 9?
Because I just said that 9 times 9 was 18.
That's what I was saying.
It's time to go home. Y'all have a good day. When I do that, that's